So this particular course, it is going to be a very interesting and interacting course, and it is a very good course for us, Internet of Things. Some of you might think Internet of Things, this is computing course and might not belong to electrical engineering. But if you're thinking that way, then you're wrong. IoT is here, and IoT is good for engineers, and IoT is good for everyone. So it's good to know about it because this is one of the technologies of the 21st century that we should be aware of and we should get involved. And as engineers, for us, we don't simply consume technology, but we get involved and create technology as well. Okay. So that under the way now, let us see how to handle this. Okay. So this course is going to be a little bit straightforward, and we have the lecturer or the course instructor, myself. I'm going to be taking you through the lecture sessions, and I will be setting your exams, marking your exams, setting your tests, marking the tests. Okay? So that is my role as the course instructor. Then we shall have tutorial assistants. Okay? These are in charge of tutorials, in charge of labs, and in charge of attendance and also evaluation during the tutorials and labs. So you have to be active and you have to respect these guys and work with them. And they are not there to do work for you, but they are there to assist you complete the work. So for every week, you will be having a tutorial activity that you will then do, engage in, do, and then you'll be evaluated on that particular activity. And the good news is that these activities will be done in groups. I've already created groups, and these groups are fixed. So you don't need to change a group from one group to another unless you're not on the list. That's when you can send me an email and then I will add you on the list. And for this particular, you're not hearing? Someone is talking. Yeah, please, when you join and you have nothing to say, please remain muted. Unless you have something to say, you can either raise your hand or you unmute and say. But I expect all of us to be like attentive, quiet, and actively listening and participating as well. So, like I said, the tutorial assistants, we have two of them. And these are fourth years, the current fourth years. They went through this course. They performed excellently well, and they have the knowledge, they have the skills, and they know how to support you to perform well and also get the knowledge and skills. Okay? And especially through the labs, we shall have lab sessions, and mostly there will be simulations. But I expect at the end of the day, each group, through the tutorial sessions and tutorial activities you'll be doing, each group will come up with a physical, at least a physical prototype of an IoT. Something small that you can present to us, and then we appreciate that you've learned something at least, and you can come up with an IoT device or an IoT prototype or an IoT project. Because this course will actually help you gain knowledge and skills to support you during your projects. Remember, in third year, you're going to start on your project work, okay? Group project work. So these are some of the courses that help you. Okay? Now, let's jump right to it. Now, I've a little bit talked about the course administration, how it will be administered, but this is how it will be done. Okay, first and foremost, we shall have lecture sessions, and these lecture sessions will be running on Wednesdays for 1 hour from 12 to 13. Okay. That is from 12 to 1. Okay. 13 is 1. You know that. And they will be via Zoom. They will be online sessions. Okay. 1 hour online sessions. And the Zoom link is already created and shared. This will be recurring. So every Wednesday, you have to log in and attend. That is what you just need to do. And attendance is not mandatory, but it will carry some mark. So if you miss, you'll miss that mark. Tutorials and lab sessions will be physical, and these ones will be Mondays from 11 to 13 hours. These are 2 hours of physical activity, tutorial sessions and lab sessions. And during this session, you'll go to class and engage in your groups, do the tutorial activities. You'll be supported by tutorial assistants. You'll be helped to complete that activity. You'll present the activity in class. You'll be evaluated in class. Okay? And you'll be, yeah, in your groups, you'll gain marks for doing that activity as a group. That means if your colleague is not around for that particular day and you've done activity, you can also earn some marks, but not full marks because you have missed. Yeah, okay. Then attendance. So I've put some attendance marks. This is very good news for you. You know, when you attend, even if you don't do much, you gain 10% of the coursework. Okay, so if you plan to attend all the lectures, you already have 10%. Lectures and tutorials and labs. So on this 10%, lectures will carry 5%, lectures attendance and tutorial attendance and labs will carry 5%. So if you miss any of these, then you not get these marks. Okay, let me first read something in the chat. Someone could be talking, saying, I'm the only one experiencing this problem. Which problem this person was experiencing? Maybe the only one. Yeah. Could be the only one. I don't know. Okay, so that's how it will be done. Now, let's and the assessment according to the curriculum, this is how the assessment is done. You have assignments, group work. So this group work is the tutorial activities I'm talking about. So you have group work, you have a test, which I have like one test, and then you have assignments that you also do, and then the final exam that is marked out of 60%, and then the total you have 100. But in all these, the attendance is captured, okay, in all these. Even the final exam, if you don't attend, you miss that. Now, what is this thing called IoT that we are supposed to learn about? Okay, what is IoT? So, IoT, like the name suggests, it is Internet of Things. Now, the interesting thing here that you might be wondering about is things. Okay, is things. Okay, remember, you know, Internet. You've been using Internet, but now, what about things? What is this that we call things? So we shall define things and also get examples of things. But before that, the Internet of Things is a network of physical devices, okay, connecting electronic sensors and software. So this is what we call an Internet of Things. It is a network. So there are devices networked and connected together, especially via Internet, to perform certain tasks with minimum human intervention. And that is very key, with minimum human intervention. So even if you're not involved in performing an activity, these devices are capable of performing the activity on their own. They act on their own and they do the job, whichever job they are meant to do. So that is IoT. If you have such a device, then it is an IoT device. Okay. Now, this signifies a shift where the internet user is no longer only people, but also the things. Okay, previously, remember the internet, whenever we talk internet, we'll be like, yeah, people connect to internet and do some work. But now we also say that things also connect to internet and do work, okay, on their own. So that is IoT for you. And now remember, these all these gadgets or devices, there are so many by the way. So many, even more than the population, the human population on Earth. Like if you see even around you, around your home, around class, you see some of these gadgets, like so many. So they are huge. And because they are huge and all connect to internet, how do we handle the addressing, the IP? IP is internet protocol addressing. Remember, each device that connects to internet is given an address, and this address is what we call internet protocol. Okay. Now we have the IPv4 that we were using previously, Internet Protocol version 4. But now this one, because of so many things connecting to internet, they get depleted so fast. Okay, the space gets depleted, and then you have no more space to connect. So what they did, they created another addressing which is based on version 6. So this one has a huge address space that may not get depleted. Okay, this one is based on 48-bit structure, and the IPv4 was based on or is based on a 32-bit. So you can see the difference. And remember, we always say 2 power n, where n is the number of bits, okay, the structure. So 2 power n, now if it is 32, it will be 2 power 32. If it is 48, 2 power 48. Now imagine the number you get. But you don't go deep into the details of that. That is computing for you that you might not go into. What we can go into now is imagining a world where everyday objects communicate and interact with each other and with us through internet. That is it. So imagine that world where we also have a relationship with other things in the world and we interact, we communicate, we do work together. So they are like our friends. And indeed, you have realized that these gadgets or the things that we have around us, they are also our friends, and sometimes we confine in them. Sometimes when you're stressed somehow, you can talk to your device and it gives you courage. With now AI around the corner, people have friends. Yes, friends. I'm sure some of you also have boyfriends and girlfriends who are not physical, but who are logical. Okay? Now, what you need to think about right now, you can pause and think about it. It is a question for just 1 minute. How many things around you are currently connected to the internet? Yeah, so, yeah. Now, those who have critically thought about this question, you can type in the chat. Type in the chat the answer to this question. Okay? You type in the chat because you need also to be active during lecture sessions. Okay? I'll wait for your answers. Be typing the answers as we continue. So now defining the thing. Okay, like I told you, what is this thing? And it is a huge thing. As you can see, we have put it hugely in capital letters. So the thing in IoT is incredibly broad and versatile. And it encompasses a wide range of physical entities. So it is physical by the IoT devices or applications or whatever. They seem to be physical. You can see them. Okay? You can see them. So you need to differentiate between what is a software that is intelligent enough and what is an IoT. This one has to be like an embedded system or something that is physical, tangible, that you can see. But now this incredibly broad ranges they have, it is not only like the device or machine or whatever, but machines, buildings, devices, animals, human beings, they can all be what? Things. Now imagine factory equipment that are like configured to be autonomous, that they can do work, they can look through themselves and see, identify a problem, like a maintenance problem, and adjust themselves to like rectify that problem without any human intervention. So that machine is a thing. That's how you can define the thing. Now, buildings, imagine smart homes. You have a smart home where when you come home, or even before you come home, you can command, or it might know the time when you're coming home, and it opens your room, aerates it, puts AC for you. By the time you reach home, like the room is super cool. Okay? So that is a smart home. Or it puts TV for you, puts your favorite channel on without you even touching it. Like you go to the bathroom when you're done with bathing, you come back and the TV is on and they have put your favorite channel. Huh? How is that? So that is a smart building or a smart home or a smart room. Now devices, they're also smart. We have smart appliances. We have wearable sensors. Yeah, these ones are very, very common. You must have seen wristbands, for example, or these wearable sensors that measure like your heart rate, heartbeat, or the ones that track like exercises you do, or walking, when you're walking, how many steps you do in a day. Then it can, from those, it can give you advice like you're not doing enough exercises per day. So all these devices, they are IoT devices and they are smart. And whenever I see the word smart, these days people use smart a lot. So that smart thing is coined from IoT. Animals can also be things. Now talk about livestock that you can track. These days they give name tags, they give tags. And these tags, they are like identifiers, RFID tags they give to livestock, and you can monitor your livestock wherever they are. You can monitor how they are eating, you can monitor how they are sleeping, you can monitor how they are breathing, you can monitor actually to know that this animal, this livestock is not well, and you can go and check it out. So that animal now becomes a thing with that the tag that you put. The human beings, don't think of IoT as only devices. Human beings can also be what? Things. For example, human beings that have implantable medical devices. They have chips that are implanted into their bodies. Like they communicate with the doctors whenever there's something. If you're sick and there's something, there's change of pressure, there's change of breathing, there's change of whatever. The doctor gets notification, okay, that you're not well or something has happened, and they come check on you. So at that particular moment, you become a thing. So these are the things. There are so many things around us. And like I said, 21st century is all about the things, IoT. Now, now here we also have a challenge here that we need to think about. These things, they are uniquely identifiable through embedded computing systems. Okay? Now think about embedded computing systems. What are these systems that we call embedded computing systems? Okay? Now, write it down and you think about it, you read about it, you know how this thing is, and what do we mean by embedded, and what do we mean by computing? How about by systems? So there are three things: embedded, computing, and systems. Just that is your assignment. But these ones are uniquely identifiable. So we shall learn about how to give unique identifiers to some of these gadgets. Okay, let's move on. Um, Now the evolution of internet. How did it come about? Okay, how did it come about? Because originally we had internet. Now, how come we have these things? We have IoT. How did it come about? So in early 1980s, we had Internet. Well, the internet is just created. Imagine 1980s. It is just how many years? A few years. It's not even. Okay. So internet was invented. Oh, there was that sort of thing called internet, and the internet was between computers. Like computers would communicate to internet, like you could have emails, check through emails, communicate with people through emails. Then in 1999, this guy called Kevin Aston is the one who coined the term Internet of Things. Okay, 1999. And you can see how you need to associate with this guy. Just write down the name and be thinking about him, how he could have coined this term Internet of Things and what was in his mind by then. I'm sure by then, if this Kevin of by then and the Kevin of today met, they might disagree on certain things. They might not have envisioned how today we would have so many things around us that are connected to internet. But that guy coined the word Internet of Things. And in 2008, 2009, okay, this IoT was officially like appreciated and people realized that the things that had connection to the internet surpassed human population. Imagine by that time, 2008, the things were more i- than the human population on Earth. The things that would connect to internet, they were more. Then the projections, now the projections, from then they have been doing projections. Okay. Now around 2023, they found out that the IoT devices were 16.6 billion connected to internet. 16.6. Now, by 2025, it is estimated that these devices are 27 billion, but these are estimates. They could be more, 27 billion connected to devices. You see the space where you can operate as engineers. You have a lot of things. And like I said in the morning, in the beginning, engineers, uh, computer science, we shall not, okay, you're not supposed to be replaced by technology because you're the creator of technology, and if you position yourself, you remain active. These other people who are consumers of technology. Technology will most likely replace what they do. But as you, electrical, embedded engineers, you know, these things, especially those who do hardware, embedding, like programming, hardware, these hardware related things, chips, what, configurations, those jobs will remain there because you're the one now creating these things. So there's no way you can think about being repressed. Okay, let's proceed. Let's go to core IoT working principle. So how does this IoT work? Now, IoT, I can see only 8 people responded to the question, but I see 26 people connected. I expect each one of us to respond to that question I posed. And you'll earn a certain mark for answering that question. Out of the 5% mark of attendance, you'll have an extra mark for answering questions as well. So we said the core IoT working principle, the one thing that we need to understand from now on for you to be able to say that I know what a thing is, you should know what the word autonomous mean. Autonomous or autonomy. That is the one that gives us the power, that gives the IoT devices the power. So autonomous interaction means that these devices primarily function without human or with minimum human computer intervention. I told you if you jump in, you have to mute. If you have something to say, you say it, but don't be there like playing with your fellow friends, kids. Okay? Because you distract people who are actively listening. Now, the autonomous, this is the thing that you need to write down and be proud of and say it every day because someone will ask you, but what makes this a thing? What makes it an IoT? You should be proudly able to answer that it is autonomous, or the autonomy that it has is the one that gives it the power to become an IoT. Now, someone will ask you, can you explain more? You'll say, yeah, I can explain because this thing can work with minimal human intervention. So even it can work without a human being. That means it is an IoT. That person will give you a tick 100%, will be like, okay, yeah, you're good. So you know what IoT means. The other thing that you need to know is that these devices are given unique identifiers and often rely on technologies like RFID. You know them. These are radio frequency identifiers, or the numbers that we give that use radio frequencies, okay? And they can identify some of these devices. So this technology is the one that we borrow to use in giving unique identifiers to these devices. And you get involved in that as well. Because even you, when you come up with an IoT product or prototype, you give it an ID so that when you are away, you can communicate to it via that. The other thing is networked connectivity. And remember, it is Internet of Things. So the word Internet now comes into the connectivity. How do we network these devices to work? So basically, these devices should connect from anywhere through various information and communication channels. Okay, so we have the network connectivity that we get involved in. But the most important thing is the decision that is made by these devices. Because if they are not making any sensible decision, then they cease to be called IoT. Yeah. So the goal is the most important, which is to um, achieve great service and value through this connectivity and autonomy. And remember, the reason why we are called, okay, why we are engineers and technologists, and is to make the human being live in a comfortable life. Did you know that? Yeah, we want to make people live happily and comfortably. Okay? So we want to make human beings happy. That is the work of engineers. But I'm sure some of you will be like, my work is just to design systems and they work. But they work for who? They work for people. And if people are happy with the work you do, then they'll be happy with you. Now, an example is like at the start, I said that imagine for you, before you reach home, you want your AC to be on because you want the room to be cool by the time you reach home. So what you do, you can send a command remotely, or you configure your AC that is, of course, networked. It has to be networked in a way that it can work, respond to commands or configurations. So by the time you reach home, it is on and it is working. When you leave home like this, it can switch itself off. Like the moment you lock your door, like you're leaving, it knows. Now you're out of the room, it can switch off the AC. When you're coming back, if you have not commanded, maybe you can say, when I open the door like this, switch on the AC. Something like that. Okay. So that is the other thing that you need to think about. Because as you learn these things, you need to be reflecting on some of the things, the everyday things that you come across. Don't just learn for the sake of learning. Learn to understand, to engage, to reflect. Yeah? Okay? And every day when you go to attend a session or a lecture, learn something new that you go with, that you're proud of, that you can talk about it. Now, the ecosystem, which I'll have questions at the end. The ecosystem. So the most important, okay, there are most important components of an IoT, and one of them is sensors. Actually, there are three. We shall look at three of them that you need. All these other ones are embedded in the three. One is that you have to have sensors. These sensors are everywhere and the ones that collect data from the physical environment. So you can have temperature sensors, you can have humidity sensors, there are so many sensors, soil, moisture sensors. There's so many sensors you can have. And these are the ones now that collect data from the physical environment. Now, this data that is collected is sent to an embedded system, what we call a computing system. Okay. And normally we have microcontrollers, processors. Okay. And these ones now the data is processed and then at the thing level is like at the hardware level. Now, after everything is done, processed well, now the commands or whatever configure the way you configured it, it will be sent through the communication network. So you have a network. And some of these networks you can use Bluetooth technologies, or we have what you call the short range wireless and long range wireless. And mostly by the IoT, they communicate through wireless. You don't have wired. Okay, it is weird. Like you can imagine having wired IoTs. So we have wireless, and mostly we have the short range if they are nearby us, or the long range if they are far away. If they are nearby, we use these the Bluetooth, the Zigbee, the Wi-Fi technologies. But if it is long range, then you can either use SMS, you can use 3G networks. Okay, you can use five. Now we have 5G. You can use WiMAX. Okay, some of you doing communication systems engineering as an elective, you learn about some of these things and you have to engage. Even you doing your projects, you will come about to these and you have to use some of these technologies for your thing to communicate well. Okay, and above all, you need to think about power, the consumption. Very, very important as electrical engineers because these things actually consume power. So you have to minimize how the power is consumed. That is your work as electrical engineers. Produce things that will not consume a lot of power. Then storage. Now remember, these sensors collect a lot of huge amounts of data. How do you store this data and how do you process it? Because remember, sometimes it is real-time data that comes in real time and it is huge. So what we do, we use what we call cloud technology. Mhm. We use cloud technologies to store these huge amounts of data and even sometimes process it um, in the cloud before we take a decision. Okay, we shall look at what we call edge computing that will help us process only data that is needed at that particular moment. You don't need to process all the data that is coming in. If it is normal data that is coming in, you don't need to take the decision. Leave the data the way it comes in. Just go through it. But if you like detect some variations along the way, then you capture that and process it. That is what we call edge computing. We shall look at that. You process and compute at the edge of the device. So analytics software, these are software that are intelligent enough to make informed decisions. Remember, these are autonomous devices. They have to communicate within themselves and make decisions. So your software has to be good enough and it has to perform what you call analytics. It has to analyze some of the data or information that comes in and make a decision based on that. And it has to be a good decision or a programmed decision based on the data. Otherwise, it might cause catastrophes. Imagine now an IoT device performing a wrong operation. No, it might cause issues. People may die or devices may fail or yeah, something like that. So it has to be really be good. Then eventually at the end of this ecosystem, you have what we call actuators or the end devices. These are the ones actually that perform the task, that do the operation. For example, if it is about temperature, they are the ones that will adjust the temperature. They are like switches. For example, at home, you have switches. These are actuators. You press a switch, it is on. You press whatever, it is off. Or you send an alert. So these tasks that are performed, they are what we call the actuators are the ones that perform these tasks or the end devices. And these are at the end, very end of the what? Of the ecosystem. Yeah, we have 20 minutes. To finish, now visualizing the IoT, we said in this ecosystem, the two extreme things that we have that seem to be physical, they are sensors and actuators, or the user device, whatever that device is. It can be actually a mobile phone. An actuator can be a mobile phone that senses something and does something. Okay. So the sensor and the actuator, sometimes in modern technologies, they are embedded together. They are in one thing. So this thing, the thing, the flow that you can see, it can be one device like this that has everything there. But sometimes they can be separate. Okay. So there are three things, like I said, you need to know the principle or the model that this IoT works on is sensor, processor, actuator model or principle. Sensor, processor, actuator. Now you need to write that down and also be practicing saying it. The sensor, processor, actuator model. When you do that, then you realize when they tell you to explain the working principle of an IoT, you in your mind, you have to know that I need to have the sensing part or the sensors. I need to have the processing part or the processor that gives the intelligence and processes the data that comes in, and the actuator that makes the decision or that is interface to the physical world and makes informed decision. Okay? These three, just basic principle, simple. Just write it down and engage with it, reflect on it. The rest of the things will be just inside there. Whenever they ask you to explain IoT, just tell them these three things. You'll be good to go. Now, these are some of the applications. Like you have now a tutorial activity that you're going to engage in. Okay. That tutorial activity is just to get you like your eyes open. You don't need to go into programming those embedded things, getting embedded devices. Oh, no, 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 no. Just use a plan, like visual. You visualize an IoT activity, you plan for it and you perform. You can use a flow chart, you can use a drawing, you can use text, you can use anything just for your tutorial activity as your solution. Okay. But you don't need to go deep into programming or understanding how these things or into identifying like actual sensors. You can just put sensor names, but you don't go into. Sorry, someone is saying something. Okay. So here I put three applications. These three, they are very, very important. Like imagine smart cities, what they do, like in traffic, they can predict accidents in traffic flow, and they can also predict like huge traffic and divert, send signals to other road users that this road has too much traffic, you can divert. Okay, on your phone, you can get a notification when you're driving, and then you can change. Or if there is an accident, it can also give notifications, accident ahead or accident, whatever. And it will monitor everything. Someone is talking, please unmute. Now, we have what we call smart healthcare systems. Like I talked about implantable sensors that we embed, chips that we embed in human beings that doctors can monitor. This is what you call smart healthcare system. Then you have industrial production, and this is where now you electrical engineers come in. Efficient prediction of working of machinery. Like you can do prediction, maintenance prediction, and some of these IoTs can adjust themselves to do the work for you. Smart metering, for example, in helping the electric distribution company to understand the individual household energy expenses and then make smart homes with connected appliances. They can also send you like notifications of how you're using your power or whatever, or so you can have these smart technologies for you. These are just high level examples, but there are so many applications you can do with IoT. And this is where you come in, like most of your applications will be based on these. Okay. Now, another thing we said, IoT is a network of networks because there are so many networks involved in them. For example, you have what you call big data technologies. This also is encompasses a huge network. And you know what big data is? It has three, it used to have three V's, but now I think there are four. You need to also read about some of these technologies so that you're not green about when they say big data. Don't say big data is for computer science or IT. No, you have to look at it because even in your sensors, we collect huge amounts of data, and this data might be categorized as big data. So it used to have three V's, veracity, over variety, over volume. Now it has over, yeah. So now there are four, something like that. So you have cloud computing, we talked about it. You have mobile internet, okay, that you can also be involved in IoT. You have sensor networks, you have artificial intelligence. Now this is the thing that has come in that will help you do analytics. Remember when we said software analytics? Now the AI does the job better, analyzing the data and making intelligent decisions. But at the end of the day, you need to think about, you need to pause and also think about security. Yes, this is the challenge we have, the integration and the security. Because if you don't do enough security within your configuration, if you don't put security features, your device or your IoT gadget can be hacked into, and people can manage it on your behalf and can cause trouble in your lives. Okay? So you need to think about security in whatever you do. Even when you make your devices, some people will ask you, even your prototype or projects, how secure is your application? Is it safe? Don't you think people can open my home when I'm not there if I make it smart? Yeah, think about that. And finally, yeah, we talked about security. Now, here, the other thing, the other challenge is interoperability. That is a new word for you that you need to understand. Interoperability means these devices are manufactured by different manufacturers, companies, and they have different standards. Sometimes integration becomes a challenge. Okay? So, but manufacturers now these days have standards they work with, and whenever they manufacture a device, they'll be like, sure, other people, it is configurable. It can work with your other devices. Mutogwe no horo kugamba man. Who is that one that is talking in the background? Who is not attentive? Is Sanya, Corin, Collins. Why are you not attentive in class? Let me mute you. And when you disturb, I will be also deducting marks. Now I know you. Okay? I know you. So I discussed interoperability. Scalability is also another thing because these things have to be scalable and there's huge data volume. There are so many devices, but most importantly, power consumption. Designing an energy efficient solution is your part. And whatever we do, we have to make sure we minimize power consumption. Then key takeaways, we are almost there. We are done. By the way, we talked about that IoT is about connecting everything to internet for enhanced value. Yeah, everything to internet. By the way, in future, everything. We anticipate that everything will be connected to internet. Everything you can imagine. Living a future where everything is connected to internet. It operates on a sensor processor actuator principle. I told you to write this down, and whenever you ask to explain or to explain or give a working principle of IoT, just remember one thing, sensor processor actuator principle. Then you know how to write the things inside. So in the exam, you already know one technique that you'll use to pass that question, and it will come in module one. In question number one, the working principle of an IoT. The scale and scope are immense from a network of networks, okay, to things, to everything. And it promises a significant societal and economic transformation. Very, very important. So I want you now to get motivated, get into the things, love this course, because that's how you get to understand. Yeah. So that's it for today from my side. If you have questions, you can engage me. If you have things to do, yeah, smart TV. People, yeah, I like the things that you're putting in here. Yeah, yeah, perfect. So you've passed today's task. All of you who have answered, you have passed the task. Okay, you have passed the task. Any questions so far? We have how many? You can ask me questions regarding either course, either tutorials, either exams, either tests, either online sessions, either physical sessions. If you have any challenge, you can raise the challenge here. Yeah. But this course is going to be interesting, and I want you to be active and engaged and involved, and don't be quiet. Sometimes I send the things on WhatsApp group and all of you are mute. Don't be mute, my dears. Just be active, like, engage, ask, comment, suggest, improve things. And also, I'll be sharing with you videos, video clips that explain some of these things. Engage with them, reflect. In fact, I want all of you to have a book, a notebook, where you put reflections. Every end of the lecture, you reflect about the lecture, what you've learned, what you still need to learn, and what are the next steps to learn better, to understand better. Just write like one page every day, in every session. Right. When you're given a video lecture or clip, engage with it, reflect. What have you learned? What is it being talked about? During tutorials, reflect. Okay? Reflect. I encourage all of you. And when we actually at the end of the course, I will need to look through your reflections and also award you some marks for that. Okay? For every activity you do, I want you to score, to earn something. It is not for fun. And this course is going to be interesting. Okay. So you can send me any queries if you have.